All right, so in lesson number 6, the last 2 questions we didn't get to in class, so I'd like to go through those with you here before we get to the homework. So for the first one, we see 2 separate logarithms that have that are separated by addition. So this addition means to make multiplication into one logarithm. So we're going to have a single logarithm, base 10, of x times x minus 1 equals log of 3x plus 12. Now, we also see that we have 2 logarithms, one on each side of the equation. One of the fundamental theories of algebra is if you have the same thing on both sides, they don't matter. Just like if I had like x squared equals x to the y, you know the y is just 2. So essentially, if you have a log equals a log, we can just cross them off, leaving us with the equation of x squared minus x, if you distribute the x, equals 3x plus 12. From here, we just have to try and get it so that everything is equal to 0, and then we can go through and solve from there. So if we go through and make this equal to 0, I would start by subtracting 3x and subtracting 12. So that'll become x squared minus 4x minus 12 equals 0. If I factor, I wind up having x minus 6, x plus 2, and I get 2 answers, x equals 6 and x equals negative 2. Now, in all logarithms, we do have to check. So if we look back, negative 2 won't work. Because if I plug in the log of negative 2, that doesn't exist. So that's a rejected answer. 6, however, does work. So that's our only solution. For the last one here, this actually, like I said in class, was an old Regents question. So for this, we have to remember that this single logarithm can be changed to an exponential equation. So I can make it x plus 4 to the second power equals 17x minus 4. So understanding how to change from the logarithm to the exponent is really your first step there. Then if you distribute all out this x plus 4 to the second power, I have x squared, 4x, and 16. So I have x squared plus 8x plus 16 equals 17x minus 4. Subtract 17x and add 4, and we wind up having x squared minus 9x plus 20 equals 0. If you factor, we get x minus 5, x minus 4, giving us 2 answers, x equals 5 and x equals 4. Now we could check that, and if we plug both of them back in, we'll actually see that this actually has 2 solutions. And for this particular problem, I'd like to show you something graphically that might help you see how you could do this actually on your graphing calculator. So if we go to Desmos here for a second. So if I graph y equals the logarithm with a base of x plus 4, of 17x minus 4, that's the logarithm. And then if I also graph y equals 2, we can see that there are actually 2 points of intersection here. Now, it would be kind of hard to see on your graph, but if you change your window a little bit, you will see 2 points of intersection. You can even look on your table of values here to see that both the value of 4 and the value of 5 give you points of intersection here. Let's move on to the homework. So in the homework, we started out pretty simple with the similar questions that we did in class. Again, just changing from a logarithm to an exponential and then trying to solve. So for this first one, I would make this 3 to the 4th power equals 8x plus 9. We know that 3 to the 4th power is 81 equals 8x plus 9 minus 9. We'll wind up having 72 equals 8x. Divide by 8, and we have x is equal to 9. Again, we can check that in the calculator. It'll work. The next one we would change to 4 to the 2nd equals 3x minus 2. Remember, logarithms are always equal to the exponent. So the two things I've just circled there, those are the exponents. So now we wind up having 16 equals 3x minus 2. Add our 2. We get 18 equals 3x, or x equals 6. Also works. For the next one, the first thing we have to do is get the logarithm by itself, so I would subtract 1. And then I would change this to a log base e. Natural logs are really log base e. You don't actually have to show this step if you could do it with mental math. So this becomes e to the 3rd power equals 2x, divide by 2. So I have x equals e to the 3rd power over 2. That would be the exact answer. If we wanted the approximate answer, we would type that in a calculator and you get 10.02. For the next one, if I plug in this into a exponential, we have 3 to the 2nd equals x squared minus 3x plus 5. 3 to the 2nd is 9. Subtract our 9. We have 0 equals x squared minus 3x minus 4. So see, our factoring skills really come up a lot in this chapter. So if we factor, we get two answers, 4 and negative 1. Now I have to figure out, well, do both of those work? Now there's a couple ways you could do it. You could plug them in and see whether or not 4 and negative 1 give you something that works. Or just like we did with the example from the end of class, we could graph both sides of this equation and see what we get. So let's go back to decimals here and try and graph this one. So if we do x base 3 of x to the 2nd power minus 3x plus 5 we again see this graph has 2 points of intersection, at 4 and at negative 1. So we see both of these answers are actually going to work. If we go to number 2, it asks us to find the X-Intercept. As soon as we see X-Intercept, I know that means to plug in y equals 0. So I have 0 equals log base 5 of 3 minus 2x. So if we have 5 to the 0 power equals 3 minus 2x, or 1 equals 3 minus 2x. Subtract 3, I have negative 2x equals negative 2, or x equals 1. So what that tells me is if I was to graph this graph will go through the point at 1, 0, and it would look something like this. Number 3 says to solve the equation algebraically. Now because of that square root, we can do a couple different things. We can make it an exponent of 1/2, put the exponent in front. We do a lot of stuff here. I'm just going to leave it for now and just see if I can deal with it where it is. So if I rewrite this, it becomes 8 to the 2nd power equals square root of x plus 3. Now, from here, we could square both sides, get rid of the radical, which is what we'll wind up doing here. So if I do 8 to the 2nd power to the second power equals the square root of x plus 3 to the second power, the radical and the square are going to cancel each other. So then I just have to evaluate. So I have the x plus 3 is going to be there, and then 8 to the second power to the second power. We just have to figure out what big number that's going to wind up being. And it is going to be a pretty big number, because essentially what you're doing there is you're doing 64 squared. So let me just type that in my calculator. And we have 4,096. Subtract 3. And we get x equals 4,093. And we could check that if we wanted to. It works. Number 4 is similar to what we were doing at the end of class. So notice we have two separate logarithms. So as soon as we see two logarithms, we want to combine them to make one big log. So I'm going to have a log with a base of x plus 3 of 2x plus 3 times x plus 5 all equals 2. So then I want to rewrite this as an exponential. So I'd have x plus 3 to the second power equals 2x plus 3 and x plus 5. Now both sides of this equation have to be distributed. So I'm just going to make a couple boxes here just so we can show the work. So if I do the x plus 3 part, this one should be kind of easy. I'm hoping that a lot of you can do this one with mental math. We get x squared plus 6x plus 9. The other one I'd assume is a little bit harder to do with mental math, and that's fine. So we get 2x squared, 10x, 3x, and 15. So we have 2x squared plus 13x plus 15. Now in trying to get this equal to 0, we want to keep our x squared positive. So I'm going to subtract x squared, 6x, and 9. I'm going to subtract that whole thing to this other side, so that all this cancels, giving me 0 equals x squared plus 7x plus 6. Then we could go through and factor x plus 6, x plus 1. We get answers of -6 and -1. Chances are one of those probably gets rejected, so let's check it. So again, we could plug them in. So if I plug in -1, -1 works, because everywhere I plug in -1 is going to generate a positive value. However, -6 does not. -6 minus 3, that's -3. If I put in -6 plus 5, that's -1. So -6 definitely gets rejected. So one solution. Now if I also solve this by graphing, which for those of you with the newer calculator, this is pretty easy to graph. You could just graph both sides of the equation and see that they intersect once. Those of you with the older calculators would be pretty hard to graph, so you really have to go by the mental check that I just explained. Hopefully this helps, and please check this before you come into class tomorrow, so if there's any questions further, we can go over them. Have a good night.